The goal of creating a more sustainable world drives Guihua Yu and his research.
We try to understand how the materials behave at a very small scale, at a molecular scale. And actually, by understanding better their physical and chemical property, we can design materials to achieve better functions, and many times it can achieve unprecedented properties and then performances to address the critical challenge in energy science, in environmental technology, and in water sustainability.
Today, the Welch Foundation salutes Dr. Yu's groundbreaking work in nanoscience, focused on providing clean water and clean energy with the 2022 Norman Hackerman Award in Chemical Research.
I think one of the unique things about Professor Yu is that he's been successful in working in a number of different areas. One of the special things about him is that he's managed to meld chemistry, physics, and material science in a way that it's clear how the application will benefit from that intermingling of those disciplines.
Words that describe him: brilliance, visionary thinking, kindness. He has this enormous passion to help students, colleagues, and humanity. He really wants to make a mark on the world to make it a better place for us to live.
Dr. Johnson and his group collaborate with Dr. Yu on one of his key areas of research, developing novel hydrogels that can produce clean water from sunlight. Their students have created molecularly engineered hydrogels that can produce enough clean water to meet a family's daily needs.
Now, to use sunlight to produce pure water efficiently could have a transformative impact on the availability of clean water on the planet, both for poor people that don't have access to clean water and throughout all uses of water technology.
Building on this work, Dr. Yu has created a polymer backbone that efficiently absorbs water vapor from ambient air and added a thermoresponsive polymer that changes the molecular bonding to then release the water controllably. Called SMAG, or a super moisture absorbent gel, his team has demonstrated how it can be used to make self-watering soil for sustainable agriculture. His goal now: to develop more cost-effective materials and improve efficiency of solar-powered water harvesting, working with industry partners to conduct field tests and ultimately scale up the approach. His most recent research leverages these polymer backbones as catalysts to split water to generate hydrogen and to remove nitrogen from the atmosphere. He anticipates that these backbones will produce other beneficial applications to address energy sustainability.
I would say his strength lies in the ability to take his work from the materials, chemistry and synthesis all the way to properties and applications and feed those systems back. What he's been able to do is make new materials and address the nanoscale architecture leading to microscale, millimeter scale, centimeter scale, and try to address structural configurations, but then see how it translates into properties and impact.
On the inorganic front, Dr. Yu is using nanotechnology to create more sustainable, ultra-fast charging batteries for clean energy storage. He has discovered new phenomena at the nanoscale in mineral-based transition metal oxides that allow him to create novel storage mechanisms from these abundant, inexpensive materials. In the classroom and in the lab, Dr. Yu is lauded as a teacher and mentor.
In addition to being a wonderful researcher, he's also an excellent lecturer, and his students rave about his capability to communicate difficult concepts in the classroom.
I think the teaching is really the most rewarding part of interaction as the professor. I think the ability to work with many young minds and then shape their interest into science and technology, I think that's really kind of the most fun part and most rewarding part.
This approach carries over to his personal life, where he and his wife Dan Wang are raising 3 children: Yuzha, 11, Yuhan, 7, and Yulan, 3.
So I think that being a teacher prepares me better as a father, because I know how to communicate in a more constructive way and in a patient way with my kids.
As a father, he's really playful. I mean, his parenting style is playful parenting. And for him, he also need a moment to be relieved from daily work pressure. So he really enjoyed all of the playful moments with kids.
Dr. Yu and his wife first met in elementary school, but didn't begin dating until college. While their majors were different, they shared a passion for finding solutions to pressing societal problems.
I think we share many of these common interests in terms of making some kind of impacts, right, on society, and also trying to also work together for this common goal of creating a better world.
I would say he definitely is a guy who inspired me a lot. And he always asked me, like, why not? And I have to say, sometimes this question annoys me a little bit. But actually, a lot of why inspire me to think more, to think deeper.
So I actually like to ask my kids many kind of whys, and for them to ask questions, but also explain in details how things work and actually what sustainability means for our society.
Dr. Yu's habit of always asking why has helped drive his research too.
I think as a scientist, the question you ask is, right, trying to explore these unknown, learn from these unknown, and then you can actually have a greater potential. So that's the reason I believe always the best is yet to come, because you don't know what's going to happen next.
By asking why and then finding answers, Dr. Yu has already made a difference, with more advances to come.
Chemistry is the starting point to develop potential or impactful materials, and he knows good chemistry, so he uses his chemistry, basic chemistry, to develop materials. I think he has intrinsic desire to do good for the society, and he works hard at it.
For his innovative research, excellence in teaching, and commitment to making the world a better place, the Welch Foundation honors Guihua Yu with the 2022 Norman Hackerman Award in Chemical Research.